Welcome. And I'm glad that you're all here. Sorry for those of you who are standing. They gave us a tech talk instead of a breakout session, but I took photos. So hopefully next year they will give us a breakout session. So thank you all for being here. Advance the slide, please. So I'm Donna Malieri, and this is Chris Anderson. We're program managers on the Azure Functions team. I'm responsible for the developer experience, including the Visual Studio tooling and the Azure Functions portal. Chris manages the runtime itself, including our application insights integration. However, for the next 20 minutes, we will be performing in a short play entitled "A Day in the Life of an Azure Serverless Developer." Chris will be playing the part of a developer who finds and fixes a bug. And through this, you'll see the emotional highs and lows as we find a bug, fix it, and deploy the fix to production. And you'll see both the inner loop of this process, which is local debugging and running locally, as well as the outer loop, where you use Azure Application Insights to find the bug, and you use publish through Visual Studio and continuous integration to push those changes to production safely. And one of the other starring members of this play will be our new Visual Studio 2017 tooling, which we're super excited about. It's based on class libraries, which I know many of you are really looking forward to. So you get the full power of everything you're used to with Visual Studio. You get IntelliSense, you get unit testing, you get debugging. Everything just works. And even more, you don't have to use a separate metadata file, function JSON, to define your bindings and triggers. We generate it for you. You use web jobs attributes in your code, and that generates a separate metadata file. You'll see that in the demo in a minute. And you can learn more about it at this blog post and download the tools. So in this sample, you can see the web jobs attributes. We have a new function name attribute, which defines what the function is. That means your method can be called anything you want. And then for triggers and bindings, you use web jobs attributes right on your parameters. So just by looking at the method definition, you can see everything that it's doing. There's no need to go look at a separate file. So let's do a really quick demo of the creation experience with the new Visual Studio tooling. So Chris has a blank instance of Visual Studio installed. He's using Visual Studio Preview, which is a preview of VS Update 3. We then have a Visual Studio extension that installs on top of that. Now, you may be worried when you hear the word preview. Don't worry. For the first time ever, Visual Studio now allows you to have side-by-side versions of the same version of Visual Studio. So you can have your regular instance of VS 2017, and you have your preview instance. They won't interfere with each other. So what Chris is going to do is he's created a new functions project using this new tooling. And it's taken a minute. And here you go. You see you got two files, host.json and local.settings.json. Adding a new function is super easy. Just go right-click, add new item, and pick the very first item in the list. Thankfully, Azure Functions begins with an A, so we're way at the top. And you can pick an HTTP trigger. Notice here what's going to happen. He's using an old build. He didn't update like I asked him to, so that's why he's seeing that error. He sits right next to me, but somehow he is able to ignore me despite this fact. The tooling itself does not have that pop-up. And you can see here it's a class with attributes. So without further ado, let's go back to the slides and take a look at the architecture of the application that we're going to be showing you today. So this is a more advanced scenario. We have an application that's hosted in Azure Storage. It's just a simple single-page app with JavaScript. And what it does is it uploads an image to blob storage, which then triggers an Azure function to process that image. So let's take a look at the code, at the actual website. So what we have here is a very popular site that is somehow business critical. I'll leave that to your imagination. That takes a photo of somebody and generates a trading card based on the predominant emotion in the face. And we use the Microsoft Cognitive Services APIs to figure out what kind of emotion they have. So if we upload a photo, Chris's photo, for instance, he's very happy, so he gets a lot of hit points. Now, when our story begins, Chris, the developer, gets a bug report from his manager. And this bug report has just about the same level of quality as what he's come to expect from bug reports from customers, which is, hey, Chris, so customers are saying when they have two names, sometimes they're just only getting their second name on the card. So can you look into that? Despite the vague bug report and lack of repro steps, Chris is not worried. Chris has Azure Application Insights. He can look at the log of everything that this app is doing, and he can look for some data that looks like it might be strange. And using that, he can figure out where the bug is. So what he's doing here is he's opening the Azure Application Insights Analytics portal. This is super powerful. It lets you write queries in a SQL-like language, and you even get IntelliSense on these queries. So if you don't even know the language, you can learn it really easily. So what Chris is going to do is look at some recent events and look to see if it looks like there's some kind of data that looks strange. And right here, he's seeing that there's some names. What's happening here is that Chris Anderson was the input, but then that turned into Anderson. So he has a sense of what's going on. It looks like if there's a leading space and there's two names in the title, then that's what causes the bug. So he has an idea of what to do. What he's going to do is he's running locally. So he's going to try to use that input and see what happens. And he's going to set a breakpoint to see when that transformation is happening and see exactly what's going on. And it looks like he's doing some string manipulation here and on the title and trying to figure out what's going on. So he's going to choose a photo and type in his name. And he's got a very appropriate title there. And we can see our breakpoint is going to be hit even though he is uploading an image to blob storage. He can still trigger off of these events. Now, his spa also has a bug. I want you to notice there. I want you to see how he had to refresh that. I've run into this bug myself. So he is indeed the maker of bugs. So now that the image actually uploaded, the blob will trigger, and you notice now we have a breakpoint. Now, this is the really awesome thing. No other cloud platform, no other serverless cloud platform has this. You can run the functions runtime locally. That's the actual functions runtime. It's not an emulator. It's not a simulator. It's the same bits we run in Azure. And you can trigger off of events that are in Azure. So you get a hybrid debugging experience. This means that it's a lot easier to repro bugs, and you get a really tight inner development loop. This is something we're really proud of, and we think that our competitors are probably very jealous of. So what Chris is noticing here is he's doing this trim to remove leading spaces. But instead of just doing a string.trim, Chris decided to get fancy and actually do some substring matching. So he's decided that he's actually not that smart to go and do substring matching himself. What he's instead going to do is what most programmers should do, which is do string.trim. And that'll fix the issue, because what he's doing here is he's looking for the last space and then truncating based on that. So of course it's going to break. And of course, he never tested the scenario where he had a leading space and 2 words. So that's what's going on here. So what he's going to do is he's going to build and run locally. This is super fast. Once he found the bug, he just runs it again to see if it fixed. So now let's pick a more exciting photo. Let's pick somebody famous. There we go, Steve Ballmer. This is awesome. Okay, so let's use that same bug, and let's see if it works out correctly. So here we go, and let's see what happens with the generated image. Do you have a breakpoint? There we go. There we go, our breakpoints are hitting, and we can see Steve Ballmer is very angry, but his name shows up correctly. Great, so Chris has fixed the bug, and Steve Ballmer has helped with his wonderful photo. And you can see Cognitive Services correctly detected that that's an angry face, although Steve would probably say it's an excited face. So now, Chris is tested locally. What's the next step? He's going to push it to Git. And we have continuous integration with GitHub enabled in Chris's dev environment. Oh, actually, that's not the next step is you're going to commit it, but you're also going to push it to your stage environment. So you can first, we have two environments here. We have one that Chris has just for himself that he can push to. And then we also have a stage environment where multiple people who are committing are going to see all their changes pushed live. So what Chris wants to do is first check to see if his own changes by themselves are okay in Azure. Now, as I said, this is the Azure Functions runtime, but we always know that things are always different in different environments. So we should test the same bug in Chris's own dev environment in Azure. So publishing is super easy. You just right-click, publish, same dialog as web app, except we have a beautiful functions logo instead. So Chris is now in his dev environment. Notice the subtle change. It says dev instead of local. And he's uploaded the photo, and it looks correct. So yay, we're good to go. So Chris is now ready to have his changes mixed with everybody else's and make sure everything works. So he's going to go to his command line and commit his change. Chris really likes the command line. Personally, I like using Visual Studio to commit, but hey, I'm not going to judge. He's the dev. He gets to decide what he wants to do. So he's going to commit the change. And if we go over to our configuration in the portal, we can see that he's set up continuous integration, and it's going to actually start building based on that change. Notice the Configured Features tab. This is new in the Azure portal. Any feature that you've customized will show up there. And so you can see now it's building. So let me show you a little bit about the environment, a graphical representation of the different environments we have here. If we go over to our slides, you can see here that we have Chris's dev environment where he's using Visual Studio and command line in order to run locally and then commit his changes. Once he commits to Git, what's going to happen is it's going to automatically push and go into the stage environment. That's the environment that's shared with the other developers. And once that finishes building, Chris is going to test it in stage. The next step is production. Now, we never want to push automatically to production. Usually there is some element of human sign-off involved. So for instance, on the functions team, we use Azure Websites for our portal, and we have a manual process where we swap from stage to production. And when that happens, whoever wants to do that sends an email to the team, and the dev leads say, yep, that looks good, we've tested it, go ahead and push that button and manually transfer. So what we're going to do now is we're going to go look at stage in the portal. By now, it should have finished building. You can see that checkbox, meaning that the build is completed. You can even put tests in here and run them server-side. And you'll also get the same experience. The change will get rolled back if your tests fail. So now we're in stage. Chris is going to test again with this wonderful image of yourself. Oh, happy he fixed the bug. There we go. And so he's inserted the same bug in there. Yes, and now it works. So now we know that even with everyone else's changes, Chris's changes have not interfered, and everything is working. Great. So now that everything is correct in stage, what we're going to do is manually sync to production, again, with that manual sign-off process. What we've done here is we're using continuous integration and deployment on the production environment, but we don't have automatic sync. So what Chris is going to do is push that sync button, and we'll see that a synchronization is happening, and notice now it's building. It's building those changes. And what that's going to do is push those changes to production once the build is done. And so that's how you can safely deploy, find a bug, use Azure Application Insights. Using your local environment with Visual Studio, you can fix the bug, and you can safely deploy to production using continuous integration deployment and also manual sync to production. So basically, the idea here is that Microsoft has this long history of making sure developers are productive. Serverless is all about making it so that you don't have to think about servers. You just have to think about your application code. However, that doesn't mean you don't need tools. So we really feel that serverless needs great tools. And that's why we've provided this unique local development experience, our new one-of-a-kind Visual Studio 2017 tooling that really puts us ahead of other cloud vendors. The other thing that we have here is tight integration with Azure Application Insights that you can even customize yourself. You can do custom metrics. You can do custom dependencies. You can do the application graph. All of the beautiful features of Application Insights, because you're taking away a little bit of control when you don't have your own server. But it doesn't mean you shouldn't know what's going on in your application. Application Insights gives you that. And we use continuous integration to deploy safely to production. Now, you can get the same code here, make your own coder card generator at aka.ms/codercards. And we encourage you to follow our Twitter handle for product news. Thank you. Thank you, Chris.